Good morning, Senior 1. We are going to start talking about some previous lessons from the middle three to complete our lessons for Senior 1. First of all, we studied the circle and we are going to revise the central angle inscribed in angle of tangency and relation between them. Firstly, if you have a circle and you have an angle, its vertex is the center and its two sides are two radii in the circle. Here we have angle AMB, its vertex is the center and its two sides are two radii in the circle, so we can call angle AMB is central angle. This is the central angle. And measure angle AMB equal measure of AB arc. Measure of this angle, for example, if it's 60 degrees, so the arc is going to be 60 degrees. Also, we studied or we dealt with a circle, and inside this circle we can find another angle. We have another angle. So, for example, angle AXY. Angle AXY. If measure this angle, its vertex on the circle and its two sides are two chords in the circle, that means this is inscribed angle. This is an inscribed angle. Its vertex on the circle and its two sides are two radii two chords in the circle, okay? So this is inscribed angle and this is angle AXY. If you look here, measure of angle AXY is going to be half measure AY arc, half the subtended arc in front of it. So if the arc is 60 degrees, then our angle is going to be 30. And from here and the previous one, we can deduce that if you have a central angle and inscribed angle subtended by the same arc, you can find the relation between them. You have an inscribed angle just like this, and the central angle just like this. You have angle AMB and angle AXB. So you can say that angle M equal measure arc AB and angle X equal half measure angle arc AB. That means in the inscribed half equals half the central. The inscribed equals half the central. If you look here, let me revise or look the reading and read the problems. Or the summary here said the measure of the central angle equals the measure of the subtended arc, and the two y's that inscribed the central to y they inscribed the subtended by the same arc, and equal to y the measure of angle of tangency. What about angle of tangency? In middle 3, yes, senior 1. If you have, and this is our third angle. If you have a circle, just like that, and we have a tangent anywhere. You have a tangent anywhere. And we have from the point of tangency, you remember, this point is called point of tangency. Point A here is point of tangency. And if we have a chord starting from the point of tangency to any chord, like AB. So we have what do we have? We have tangent and chord, tangent and chord. So BAX, for example, is called angle of tangency. Angle BAX is angle of tangency. Angle BAX equal angle of tangency. So it's subtended by tangent and a chord. So we can have a part inside the circle and a part outside circle. And it's also equal half its arc. Half its arc. يعني half means half AB arc. Half AB arc. Like what? Like the inscribed angle. Like our inscribed angle. So we have angle of central and inscribed and the angle of tangency. Next, if you remember, the measure of inscribed angle equal dots, the central angle subtended of it. The inscribed, the dots, the central. So it's half the measure. Okay, the ratio between the measure of a central angle and the measure of an inscribed angle that had the same subtended arc. The central twice the inscribed. So it's going to be 2 to 1. Another question. The measure of central angle equal 100 degrees. Then the measure of subtended arc is inscribed subtended by the same arc. It will be its half, so it's going to be 50. Look here, we have some questions. We have CA and CB two tangents, CA and CB two tangents to the circle. Measure angle C equals 70. He asked to find the measure angle ADM. Measure angle ADM. Look carefully. If you have a radius and the tangent, another time, if you have a radius and the tangent, so we have a right angle here, right? Also, if you have a radius ABM and the tangent, so we have an angle 90 degrees. Then, what about measure angle AMB? Angle AMB, it's going to be 360 minus 90 plus 90 plus 70, it's going to be 110 degrees. So this angle is going to be 110. What is the relation between angle AMB and angle D? This is central and this is its inscribed. So it's going to be half its measure. So it's 110, this is going to be 55 degrees. Next question. AM bisects angle BAC and the ACM equals 25 degrees. Find the measure BC arc. You know that BC arc could be equal to measure of BMC angle or double measure angle BAC because this is an inscribed another time. AM bisects this angle. So if this is 25 and this is going to be also 25 and this is AM bisects angle BAC, so this angle AO will be 50. Angle ABAC is going to be 50. That means that the arc BC is going to be 100, double the inscribed angle. Here, AB is the diameter, AB is the diameter in the circle, and the XY is the tangent. XY tangent at B. Measure A and C40, measure A and C40. So what about measure angle B? It's going to be half the angle A and C because it's inscribed on the center. So this is going to be 20. And measure CBY. He asked about CBY. What about we have tangent and radius. So this whole angle is going to be 90. 90 minus 20 is going to be 70. Next, we are going to study the cyclic quad. We are going to study the cyclic quad. Look carefully in the little 3 or senior 1. If you want to study the cyclic quad, you must remember something. If we have a circle and we have many inscribed angles subtended by the same arc. Many inscribed is subtended by the same arc. So all of them are going to be equal in measure because all of them subtended by the same arc. For example, AB. For example, it's AB arc. So instead of that, or by adding to that, if you have a circle and we have an inscribed angle, we have an inscribed angle just like that, and another one just like that. Can you see them? We have A, B, D angle and A, C, D angle, and each of them inscribed, subtended by the arc AD. Here that means they are equal in measure. That means if you have a circle passing through A, B, and C, and D, if you have a quadrilateral passing through them, just like that, that means this is a cyclic quad. So if measure angle 1 equal measure angle 2, if measure angle 1 equal measure angle 2, and they have common base, so this shape is cyclic quad. This shape is going to be a cyclic quad. So what about the cyclic quad? The properties of cyclic quad, or how can I prove that the shape is a cyclic quad? Cyclic quad has many properties. First of all, the previous one. The previous one, which was, if you have a cyclic quad just like that, four vertices lie on the same circle. First of all, four vertices lie on the same circle. So this is a cyclic quad. Or if you have two angles have same measure, and have common base, and all of them on the same side of this face. So this angle 1 equal to angle 2. If measure angle 1 equal measure angle 2, and they have same base, common base, and they both up, so this is a cyclic quad. What about if angle 3 equal angle 4? What about if angle 5 equals angle 6? They have the same base, right? What about angle 7 equal angle 8? They have the same base, so they are all equal. 7 equal 8, 1 equal 2, 3 equal 4, because each one of them have common base and on the same side of this base, so this is cyclic quad. Third property of a cyclic quad we are going to deal with is going to be each two opposite angles are supplementary. Each two opposite angles are supplementary. That means angle A, measure angle A plus measure angle B is going to be 180. Measure angle C plus measure angle D equal 180. Number 4, or the fourth case of cyclic quad, if you have a vertex like A and you go out like here, like AX. So what about this angle? This angle is going to be exterior angle. The measure of the exterior angle equal the angle of opposite to its vertex. Opposite to the vertex in front of it. So angle XAC equal angle B. Measure angle XAC equal angle B. The exterior equal the one in front or opposite to its adjacent. The opposite to its adjacent. Let me see a question on it. To remember together the cases, or the cases of a cyclic quad, or when I have a cyclic quad, what do we have? In each of the following, A, B, C, D is a cyclic quad. Can we have a cyclic quad without drawing a circle? Yes, we can just get a property of a cyclic quad. So we decide that this is a cyclic quad without drawing a circle. He said that A, B, C, D cyclic quadrilateral, find the measure of each angle. Okay, this is a cyclic quad. Let me remember with you properties. If you have cyclic quad, so each two opposite angles are supplementary. Each two, the four vertices lie on the same circle. The exterior equal the angle opposite to its adjacent. Okay? If you have common base and the two angles up or down, the common base, they are going to be equal. So here, if this is 32, this is going to be 32 because they have common base AB. And here, if you have angles ACB 30, so ADB is going to be also 30. And this angle is 100, so this angle also is going to be 100. He asked about which angle? He asked about this. So in this triangle ADB, this angle is going to be 180 minus 100 plus 30. This is going to be 50. Then this is also going to be 50. What else? What about this? It's going to be 150. Another time. So let me solve it again. Let me say it again. This angle is 30, so this angle also is going to be 30. And all of this angle is 100, so this all is going to be 180 minus 100 directly, instead of getting the 30. So this is 30, this is 100, so this is going to be 80. This is 30, so this is going to be 50. So this is angle 30 and this angle is 50. Look at this one. What do we have here? We have measure angle ADB equal 25 and the ACD equals 65 and the DBC equals 45. From the 25, what can we get? We can deal with common base, so this is going to be 25. So the first question, ACB 25. And what about DBC and DAC 44? So this is going to be 44. What about BAC? It's going to be like BAGC. We don't have it. So let's find the BGC. It's 180 minus 65 plus 25. It's going to be 90 plus 44. So it's going to be 8 minus 4, 4. So this is going to be 46, and also this is going to be 46. Do we have something else? No, we have got every angle here. Which of the following figures can have a circle passing through the points of A, B, C, and D, and mention the reason? Tell me which of these could be a cyclic quad. Look here, this line parallel to this line, so this angle equals 38 alternate, right? So here 76. That means this exterior, so we make 76 minus 38, we got that it's also 36. 38. So we have two angles, have common base and have the same measure, 38. So this is a cyclic quad. This is a cyclic quad. What about this one? Here we have AD equal CD, and this angle is 60, and this angle is 85, and this angle is 25. In the larger triangle, we can say that this is 25 and this is 60. It's going to be, if we look here, this is going to be 85 and subtract, this is exterior about the triangle ADE. Subtract the 85 minus 60, so this is going to be 25. If they have equal size, so it's also going to be 25. This is 25 and this is 25. So this angle equal to this angle, and they have the common base. Can you see that? AD common base, and so and ABD equal ACD. So this is also cyclic quad. And here you have the third one. Is this a cyclic quad or not? This parallel to this. That means this angle equal to ADB equals DBC alternate. And by the way, this is equal to isosceles triangle, so this angle equal to this angle. ACB equals DCB. From 1 and 2, this angle equal to this angle, and they have common base, so this is a cyclic quad. Cyclic quad. Thank you, Senior 1, and see you in the next video.